Gram-Schmidt orthogonalization process. So it is a systematic method, and this method, it is used to convert a set of linearly independent vectors into a set of mutually orthogonal or orthonormal vectors that span the same vector space. So you have linearly independent vectors. Those linearly independent vectors, you're going to convert to an orthogonal vector or an orthonormal vector using the process called as Gram-Schmidt orthogonalization process. So first I will tell you the process how to find the orthogonal vectors from the linearly independent vectors. For that, suppose we are going to take the linearly independent vectors are v1, v2, etc. vn. Okay, so these are linearly independent vectors. So step 1, what we are going to do is, we are going to take, that is, we are going to find orthogonal vectors for this linearly independent vectors. So we are going to name that orthogonal vectors as u1, u2, etc. un. Okay, so v1, v2, vn are linearly independent sets, linearly independent vectors. From these vectors, we are going to find orthogonal vectors which are u1, u2, etc. un. So step 1, we are going to take u1, that is the first orthogonal vector, as the first linearly independent vector itself. So we are going to name it as u1 is equal to v1. This is step 1. Okay, now coming to step 2. In step 2, what we are going to do is, we are going to find what is u2. So how we define this u2 is v2, that is the linearly independent vector v2 minus the projection of v2 on u1. Okay, this is how we define the orthogonal vector u2. Next, we are going to define u3. How do you write u3 is v3 minus projection of v3 on u1 minus projection of v3 on u2. Okay, so what is this projection actually? Projection of u on v. The general definition for projection is u dot v divided by, v dot v into v. So the projection of u on v is equal to u dot v divided by v dot v into v1. Okay, so now finally the kth term. How do we write the kth term is uk is equal to vk minus the general form. We'll write it as summation of projection of vk uj, where your j lies between 1 to k minus 1. Okay, so how do we find u1, u2, u3, uk is by using these formulas. u1 directly, the first linearly independent vector would be considered as your u1. u2 is nothing but v2 minus projection of v2 on u1. Likewise, you have u3 and the general form. So this is the process of finding your orthonormal vectors. Okay, so now what we are going to do is, we are going to solve a problem based on this Gram-Schmidt method. So we have vectors v1 is equal to 1, 1, 0, v2 is equal to 1, 0, 1, and v3 is equal to 0, 1, 1. So we are going to find the orthogonal basis and orthonormal basis for these vectors. Okay, so the method, the steps whichever we have already defined, we are going to use the same thing, and this is done by using Gram-Schmidt method. Okay, so the first step, you are going to take u1. So u1 is nothing but v1. So v1 here is 1, 1, 0. Okay, so first step is over. Secondly, you are going to find what is u2. So u2 is nothing but v2 minus projection of v2 on u1. Okay, so u2 is nothing but v2 minus v2 dot u1 divided by u1 dot u1, the whole thing into u1. This is according to the definition of your projection. Okay, so what is v2? v2 is the vector 1, 0, 1 minus, what is v2 dot u1? v2 dot u1 is nothing but 1, 0, 1 dot u1 is nothing but 1, 1, 0. So both the things you are going to multiply. So when you multiply, it will be 1 plus 0 plus 1, which is equal to 1. So the numerator here is 1. Okay, next one, for the denominator part, you need what is u1 dot u1. So u1 dot u1 would be equal to 1, 1, 0 into 1, 1, 0. So the dot product would be 1 plus 0, which is equal to 2. So your denominator part would be 1 by 2, and your u1 is nothing but 1, 1, 0. u2 would be equal to 1, 0, 1 minus 1 by 2, 1 by 2, 1 minus 0. Okay, so 1 minus half would be half, 0 minus half would be minus half, and 1 minus 0 would be 1. So this is your u2. Okay, now coming to u3, u3 would be nothing but v3 minus projection of v3 on u1 minus projection of v3 on u2. Okay, so v3 is nothing but, according to the question, v3 is nothing but 0, 1, 1 minus projection of v3 on u1, we write it as v3 dot u1 divided by u1 dot u1 into u1 minus v3 dot u2 divided by u2 dot u2 into u2. Okay, so rest of the things we have to find. Okay, so now we are going to find what is v3 dot u1. So v3 dot u1 is nothing but V3 value is 0, 1, 1 into U1 is nothing but 1, 1, 0. So when we multiply both the things, we'll get it as 0 plus 1 plus 0, which is equal to 1. Okay, so it is 0, 1, 1 minus the numerator part here is 1. We have found previously what is U1 dot U1. U1 dot U1 was nothing but 2. Okay, into U1. U1 is nothing but 1, 1, 0. Minus, next we need what is dot U2. So V3 dot U2, V3 value is nothing but 0, 1, 1 and U2 value is nothing but 1 by 2 minus 1 by 2, 1. So when you multiply, you will get it as 0 into 1 is half is 0 minus half plus 1, which is equal to 1 by 2. So the numerator part is 1 by 2. Now coming to the denominator, U2 dot U2. U2 dot U2 is nothing but 1 by 2 minus 1 by 2, 1. 1 by 2 minus 1 by 2, 1. Both the things you multiply, you'll get 1 by 4 plus 1 by 4 plus 1, which is equal to 2 by 4 plus 1, or it is 2 1 2, 3 by 2. Okay, so you'll have 3 by 2 into U2. So U2 is nothing but 1 by 2 minus 1 by 2 and 1. Okay, so now on further simplification, what you'll have is, you'll have 0, 1, 1 minus 1 by 2, 1 by 2, 2 into 0 is 0. This 2 and this 2 will get cancelled. That will be 1 by 3. Okay, so 1 by 3 into 1 by 2 would be 1 by 6 minus 1 by 3 into minus 1 by 2 is minus 1 by 6, and the last term would be 1 by 3. Okay, so now when you subtract, you'll have 0 minus half minus 1 by 6. So minus half minus 1 by 6 would be minus 4 by 6. Okay, so it is minus 4 by 6. Next one, 1 minus half is half. Half minus of minus 1 by 6 is half plus 1 by 6. Again, you will have 4 by 6. Okay, and finally it is 1 minus 0 is 1. 1 minus 1 by 3 is 1 minus 1 by 3 is 2 by 3. Okay, so the first two terms, it can be further simplified. So it is minus 2 by 3, 2 by 3 and 2 by 3. Okay, so now we got the value of U1, U2, U3. These are called as your orthogonal vectors. Okay, so these three vectors are your orthogonal vectors. So now what we are going to do is we are going to normalize. So normalizing is nothing but you are going to write the unit vector for this. Okay, so for U1, the normalized vector, we are going to name it as E1. So E1 would be U1 by norm U1. Likewise, for U2, it will be E2. So U2 by norm U2, and E3 is equal to U3 by norm U3. Okay, so first we'll find what is norm U1. Norm U1 is nothing but square root of 1 square plus 1 square plus 0 square, so which is square root of 2. Likewise, for norm U2 would be square root of 1 by 4 plus 1 by 4 plus 1. So it is nothing but 2 by 4 plus 1. So 2 by 4 you can write as 1 by 2. So it is 3 by 2. Next one, norm U3. So norm U3 you can write it as 4 by 9 plus 4 by 9 plus 4 by 9. So it is root 12 by 9, or you can write it as 4 by 3. Okay, so this is your norm U1, U2, U3. From that you have to write what is it, E1, E2, E3. So E1 is nothing but 110 divided by root 2, or you can write it as 1 by root 2 into 110. Likewise, E2 would be equal to 1 by root 3 by 2 into half minus half 1, and E3 would be equal to nothing but 1 by root of 4 by 3 into minus 2 by 3, 2 by 3 and 2 by 3. Okay, so U1, U2, U3 are called as your orthogonal vectors. E1, E2, E3 is called as your orthonormal vectors, and these orthogonal vectors and orthonormal vectors are found by using your Gram-Schmidt method.